This is Algebra Lesson 6-6, Systems of Linear Inequalities. A system of linear inequalities are two or more linear inequalities together, which means they're graphed on the same set of x and y axes. The solution to the system is the solution or set of solutions that makes all the inequalities in that system true. This is designated by shading, and it's where you shade one inequality in one color, you shade a second inequality in a second color, and where the two colors overlap, that happens to be where the solution is. So when you're going to solve a system of inequalities, the first thing you're going to do is you're going to graph your first inequality with the proper boundary line and shade it in one specific color. Then you will graph your second inequality with its proper boundary line and shade it in a different color. When those two colors overlap, then you will have your solution to your system. Let's take a look at a couple of systems here. In problem number 1, we have two inequalities. I will aptly number them 1 and 2. 1 is written in slope-intercept form, so it's very simple to graph this particular inequality because it's already in slope-intercept form. So if I graph inequality 1, y is less than negative x plus 3, my y-intercept is 0, 3, and my slope is down 1, right 1, so down 1, right 1, down 1, right 1. It happens to be a dashed line, so I'll be sure to make it a dashed line. And it looks something like this. Just tweak it just a little bit here. There we go. So once I have this where I want it, I need to figure out a test point to shade it. Since it does not go through 0, 0, I can test 0, 0. So I am going to label it really quickly. If I tested 0, 0, I would have 0 is less than 0 plus 3. 0 is definitely less than 3. So that is a true statement. So I'm going to shade toward 0, 0. And I'm going to do this with a crayon now because a highlighter doesn't work when I'm shading these particular problems, because highlighter over highlighter kind of just melds to the whatever highlighter you use last. So I would be shading in this general area. Okay. Now for the second inequality, I need to put it in y equals form first, because using intercepts isn't going to work because it's equal to 0, so you're only going to get one intercept. So if I solve this for y, I get 4y equals 2x, divide both sides by 4. Y is greater than or equal to, not equal to, greater than or equal to 1/2 x. Okay, so my y-intercept is 0. I'm going to go up 1, right 2, up 1, right 2, up 1, right 2. Now, interestingly enough, when you graph systems of inequalities, you do not need to name the intersection point where the two graphs cross. In fact, if you do that, it kind of throws people off. So it's probably not a good idea to name the intersection point unless specifically it asks you to. So this particular graph is a solid line. All right, so we'll do a solid line for this one. Adjust slightly. There we go. To shade this one, I'm still going to use a test point, but I can't use the point 0, 0. Okay, because the graph goes through 0, 0. So I can choose any other point that is definitely not on the line. It is definitely above the line or below the line. And it's a little bit easier if you use something that has a 0 with it. So I'm going to pick the point 6, 0. Okay, that means x equals 6 and y equals 0. So if I pick the point 6, 0, that's the point I'm going to test. If x is 6, that's going to give me negative 12 plus y is 0. That's y is greater than or equal to 0. Well, that's a false statement. Negative 12 is not greater than or equal to 0. So I am not going to shade on the side of my line where my yellow dot is. I'm going to shade on the other side of the line. So let me grab a different colored crayon. Let's go with red. Okay, so now I'm going to shade up here. Okay. And when I do that, you can see that the section they overlap is right here, this section of the two graphs right here. So that would be the solution to my inequality. So last thing I have to do here is make sure that I have labeled both my equations and labeled my x and y axis. So the solution is that reddish purplish blob that I darkened in a little bit, and that's the solution to both of those inequalities. Now, I'm not a particularly huge fan of overlapping colors because they can get really sloppy and messy, and sometimes it's hard to determine exactly where your shading section should be. So I'm going to teach you a little trick that I am going to do for problem number 2 here so that I can determine where I'm going to shade. Problem number 2 has 2 equations written in standard form. So I'm going to use intercepts to graph these. So in equation 1, if I use my x and y axis here, if x is 0, that means 3y equals 12, which means y is 4. If y is 0, that means 2x equals 12, so x is 6. So I will plot the point 0, 4, that's the y-intercept, 0, 4, and 6, 0, that's there and there. Okay, it happens to be a dashed line, so I will go and make my line dashed. And it should be blue because that's the color I'm using. Oh, I missed massively. Let's fix that. There we go. So there's equation number 1. I need to test a point. I'm going to test 0, 0. So if I test 0, 0, I will get 0 is greater than 12, which is false. So I'm not going to shade where 0 is. So I can indicate this by just putting little arrows. I'm going to shade away from where 0 is, so I'm going to shade on this side of this line. Okay, now I'm going to do equation number 2. If I use my x and y intercepts again, if x equals 0, I get 2y equals 12, so that's 6. If y equals 0, I get 3x equals 12, so that's 4. So here, we're going to go, my x-intercept is 4, 0, that's this point here. My y-intercept is 0, 6, that's this point right here. Again, it's a dashed line. Okay, so I've got all that stuff that I need here. I'm going to dash my line here. Came close. I almost made it. There we go. There's equation number 2. Now I'm going to test a point here, so I'm going to test 0, 0 again. So I will have 0x plus 0y, which both is 0, is less than 12. That's true. 0 is less than 12. So I need to shade to the direction where 0 is going. So on equation number 2, I need to shade this way. So you can see where the arrows are pointing at each other would be in this section right through here. So I'm going to shade this. Now I can shade with a highlighter because I only need to have this little section in here shaded, because I'm not going to use overlapping shading. I'm just going to use one shading because I've used my arrows to determine where I'm going to shade. Okay. If you prefer to do overlapping, that's fine by me. If you like it a little bit neater and you only have to want to shade once, then you can use the arrow system that I use here. It makes it nice and easy to determine exactly where your solution is. All right. You can combine your knowledge of linear equations with your knowledge of inequalities to describe a graph using a system of inequalities. Okay, so we're going to write a system of inequalities from the following graph. We have 2 lines. We have a solid line and a dashed line. So I'm going to label the solid line line 1. I'm going to label the dashed line line 2. Okay, so if I knew what the slopes and y-intercepts of these lines were, I could probably figure out if I could write the inequality in slope-intercept form pretty easily. So if I look at problem number 1 here, or graph number 1, I can see that the y-intercept is this point right here, which is the point 0, 3. So B is the point at 0, 3. Now let's take a look at my slope. Okay, from this point to another point. Here's another point on that line right there. Okay, I can clearly see that there's another point right there too. Okay, so if I go down 2 and right 1, I get to that point. Down 2 again, right 1, I get to this next point. So my slope has to be -2 or -2 over 1. Okay. So in the equation, it would be y equals, okay, sorry, didn't mean to put the equal sign all the way over there. Y equals -2x plus 3, but I need an inequality. Okay, so the first thing I'm going to do here is I'm going to think about testing something. I'm going to test 0, 0. Okay? And I'm thinking it's looks like it's above the line or to the right of the line, so I'm going to think greater than or equal to. Okay, so that's what I'm going to test. I'm going to test to see if this greater than or equal to is actually correct. So if I put in 0, 0 into the first inequality here, I'm going to have 0 is greater than or equal to 0 plus 3, which is false. 0 is not greater than 3. So I don't shade where 0 is, and that's exactly where this one's going. So this is the proper inequality for the first equation, or the first line. My second line here, okay, I'm just going to do it in a different color because I think that might be easier. So let's look at my second line here. If I look at my second line, the y-intercept is right here, which would be at the point 0, negative 3. So b is 0, negative 3. To find my slope, I'm going to count up, and it goes to this blue point right here again. So I'm going to count up 1, 2, 3, 4 squares to the up and 1 square to the right. Means that my slope here is 4 over 1, or just 4. So I would have y is something greater than or equal to, less than or equal to, or in this case greater than or less than 4x minus 3. Right? It looks like it's going to the left of that line, which means to me I'm thinking it could be less than, but I could be wrong. All right, so I'm going to put a less than symbol in here, and I'm going to test it. I'm going to test it using 0, 0. So if I test 0, 0, I'm going to get 0 is less than negative 3, which is false. Okay, and that would be shading towards 0. So this inequality symbol, the less than inequality symbol, is wrong. So I need to change it to a greater than inequality symbol. So now I know that it is correct. Okay, because now I'm going to have, if I test 0, 0, okay, if I test 0, 0 here, I would have 0 is greater than negative 3, which is true. Okay, 0 is greater than negative 3, and I would be shading towards 0 that way. Actually, yeah, so this inequality is y is greater than 4x minus 3. So we've written both of the inequalities that help to describe that system. The last thing we're going to do is we're going to look at a real-world situation. Okay? You can use systems of inequalities to solve real-world problems. Here's a good example of one. A dog walker earns $15 per hour. She also earns $12 per hour for babysitting. She wants to earn at least $300 next week, but she can only work 30 hours max. She can work no more than 30 hours. What is a graph showing how many hours she can work at each job? Okay, since we're talking about each job, let's let x equal the number of hours walking dogs. And let's let y equal the hours babysitting. Okay. So one of the things we're going to talk about is just how many hours she can work. She can only work a maximum of 30 hours. So the number of hours she walks dogs plus the number of hours she babysits has got to be less than or equal to 30 total hours. That is one of our inequalities. Totally just done on how many hours she can work. The second inequality is going to be based on how much money she can earn. Okay, she earns $15 an hour walking a dog, and she earns $12 an hour for babysitting. So in my second equation, I would have $15 per every hour walking the dog, plus 12 hours for every hour babysitting, and she wants to earn at least $300. That means greater than or equal to 300. So there we go. We've got the two inequalities that we need. Now, interestingly enough, I do not need anything other than quadrant 1 simply because I can't walk the dog a negative number of hours. And if I am working, I'm not going to earn a negative amount of money. Right? So I am going to use this lovely graph here, and I'm going to take my two equations, and I'm going to use the intercepts to solve for them. So in equation 1, if x equals 0, y is equal to 30. And if y equals 0, x is equal to 30. That was fairly simple. That was a terrible 0. There we go. In equation number 2 here, if x is equal to 0, we have 300 and we divide it by 12. If you take 300 divided by 12, you get 25. And if y equals 0, we're going to have 300 divided by 15. 300 divided by 15 is 20. So those are my intercepts. So I can look at this and go, ooh, this is nice. Every one of those numbers is a multiple of 5. So now I know what I want to graph, the interval I want to use on my graph. So I'm going to let all my intervals be 5. So 5, 10, 15, 20, 25, 30, 35, 40. Okay. I'm going to actually label every other one. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. There we go. I'm going to label my axes, and I'm going to relabel this because this is messy and hard to read. So this is 10, 15, 20, 25, 30, 35, 40. Okay. And this is X, if you remember, is the hours walking dogs. And the y-axis was the hours babysitting. It is really hard to write sideways. There we go. That's better. Not great, but works. All right, so I have all my axes labeled, so now I can just simply graph my graphs. So in my first equation, my intercepts are, the x-intercept is 30, 0, the y-intercept is 0, 30. So I plot those 2 points. It's going to be greater than or equal to, so it's a solid line. All right, and I'm going to draw that line. Oh, blue is good. I like blue. Blue works. Okay. I'm going to shade this. If it's greater than or equal to, less than or equal to 30, 0 plus 0 is less than 30. That's true, so I'm going to shade toward 0. So we would shade this way in equation number 1. Number 2, 0, 25, and 20, 0 means my x-intercept is at 20, 0. And my y-intercept is 0, 25, which is here. Notice how close together these lines are. Okay, they're really, really close together, which is okay. But now you know why you have to be fairly accurate. Wow, that was a terrible line. And graph that slightly better. There we go. This is equation number 2. If I look at number 2, if I test the point 0, 0, I'm going to have 0 is greater than or equal to 300, which is false. So I'm going to shade away from 0 on this one. So we're going to shade this direction. So it's between these lines that I'm going to shade. All right, so I'm going to shade between these lines. I'm going to do it in a nice green color here because it will show up really, really well. So this would be my solution, including any point that lands on that line, either one of the lines. Okay. So that's the graph that shows how many hours she can work each job. And you can actually pick points. I could choose a point. I could choose a random point here, and I'm going to choose one. Let's say I choose this point here. That point here is 15:10, which means she could spend 15 hours walking dogs and 10 hours babysitting, and she would earn $300 or more. Okay, and you can check that. In fact, let's do that. If she wants to earn, if we did the point 15:10, that means x is 15 and y is 10, and we want to know money, so we're going to do 15 times 15 plus 12 times 10, and we want that to be greater than or equal to 300. Right? 15 times 15 is 225, and 12 times 10 is 120, and 225 plus 120 is 345. So that works, doesn't it? $345 is definitely greater than $300. So she'll earn at least $300 if she walks dogs for 15 hours and babysits for 10 hours. So if they did ask you, if the problem asked, give a possible answer, then you can just pick a point that's in your shaded area and interpret it based upon your graph. All right, closure question for today. Can the solutions of a system of linear inequalities be listed explicitly? Okay, can the solutions, that means all the solutions of a system of linear inequalities, be listed explicitly?